Okay, my awesome friends. So now we're at 32-bit. We figured out 8 and 16. I got you caught up to where we did on the PowerPoint. 4,294,967,296 possible codes. We're going to use Sean, the supercomputer, and we're going to have him crack these codes 10 seconds at a time. So rather than stop at intermittent steps here, I think what we're going to do is we're going to try to attack the whole thing in one big calculation. Okay, so that's the number of codes we have. We know that Sean can do one code every 10 seconds. So I'm going to go 10 seconds is one code. But I'm not going to multiply that out right now. I know that the codes are going to cancel. And that's fantastic. That's fantastic. I'm just going to keep the math going. Keep the conversion math going. Because I want to change seconds to minutes. 60 seconds is 1 minute. And then we're going to do minutes to hours. So 1 hour is 60 minutes. And then while we're at it, let's go hours to days. And then I'm out of board, unfortunately, and we're going to have to figure this number out and then take that result and reconvert it. Knowing, of course, if we had more board space, we could just keep going, but we're going to have to take a pause here, I think, in the middle here. So we're going to go 1 day is 24 hours. Now, look at what cancels. Seconds cancel, minutes cancel, and hours cancel. The only unit left is days. That's hard to read because I ran out of board, but that's day. So when I do all this math, I'm going to know how many days it takes me to crack this many codes. So it's this 4 billion times 10, which is going to be 40 billion, 42.9 billion. And then I have to divide that by 60 times 60 times 24. Okay? It sounds ridiculous, but it can totally be done. So what I'm going to do is I'm just going to write these numbers down so we can see them. 4294, 967, 296 times 10. And then I'm going to divide that by 60 times 60 times 24. And what comes out will be in days, because that's the only unit that's left. All right, here we go, my friends. Here we go. Times 10. 2. Divided by 60 times 60 times 24. Let's make sure I got everything in there right before I hit enter. Okay, I got it. That is going to be 497,103 days. Compare that number to 7.6 days. It's a bit more. As a matter of fact, I think we need to knock that down into years. So let's take it. 497, 103 days. And then we're going to multiply that by, let's do 365 days. I know that there's technically different numbers of days, but let's just use 365 to get us close. In 1 year. So then I have to take my 497,000, blah, 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 and divide that monster by 365. Let me get the whole thing grouped here, divided by 365. And I end up with about 1,361 years, 32-bit. About 1,361 years. 43 minutes for 8-bit, to 7.6 days for 16-bit, to 1 1,361 years for 32-bit, and now you're starting to see, hopefully, why people keep telling you to change your password. Computers are very, very good at cracking the code on these kinds of passwords. And the more bits of security we have, I didn't even bother writing out a 32-bit code because I had a hard time counting and writing and being interesting. But the more encryption we have, the safer, the harder it is to brute force it, which means the safer your data is going to be. Now, 32-bit is still, as crazy as that sounds, 1,361 years, it's actually not that crazy at all. And what I want to do is, I want to give you one thing to think about before we go any further. Take all this away. Take all this away. Okay. Go back to here with the 4 billion codes. We were under the assumption that Sean could test one code every 10 seconds. But here's the problem. Modern computers don't test one code every 10 seconds. They test about 1 billion codes every second. It's impossible for us to even comprehend that kind of speed, because in the amount of time it took me to just say the sentence I just said, they would have found the 32-bit code. Because check this out, look at the numbers. This is 4 billion codes. This is 1 billion codes every second. That means in just over 4 seconds, this computer will have tested every single 32-bit code. That's not really secure. I mean, if you can brute force 1 billion codes a second, you can get through all of those in just over 4 seconds, 4.29 seconds to be precise. So that's why 32-bit isn't good enough anymore. It was okay when we had slower computers. I believe in the 1990s, 40-bit was kind of the beginnings of like online internet security. But then processing speeds get faster, which means that 40-bit is there's not enough encryptions. So then they bump it up to one of the ones you'll look at on your optional quiz is 64-bit. And then processors get faster. And then they bump it to 128-bit, and then processors get faster. And now I believe we're at 256-bit. But when processors get faster, I guess we'll then go to 512, and then we'll just keep going. So we'll end up, it's this cat and mouse game with as processors get faster, hackers get better at cracking encryption, so encryption has to get stronger. And that's the kind of cat chasing its tail that we have to deal with. But anyway, I hope this helped, and have a good time with the optional quiz if you want it.